Laws of indices. Let's begin by knowing what are indices. We go to the definition. An index, this is what we refer to as indices in plural. It refers to the number of times a given number multiplies itself. It is also referred to as the power or the exponent. An example, given 2 raised to the power 5, that means it is 2 times 2 times 2 times 2 times 2, meaning 2 has been multiplied by itself 5 times. So therefore, in 2 raised to the power 5, 2 is referred to as the base, and then 5 is referred to as the power or the index, or you can also refer to it as an exponent. Let's go to some important laws of indices. We start with the first one, multiplication law of indices. Given that a raised to the power m multiplied by a raised to the power n is the first law. This one we solve it by taking a and then we get the sum of the powers. So this is why we have the bases are the same, but the powers are different. But the most important thing is when you find the bases are the same, you simply add the powers. An example, given 2 raised to the power 5 multiplied by 2 raised to the power 1, the bases are the same, 2 and 2. So you add the powers, you get 5 plus 1. This one gives you 2 raised to the power 6, which is 64. That is the first law of indices, the multiplication law. The second one is the division law. Given a raised to the power m divided by a raised to the power n is equals to a m minus n. So the division law, we subtract the powers. Something very important to note, the bases are the same. The base here is a. So when you're dividing, you simply get the difference of the powers. An example, 3 raised to the power 5 divided by 3 raised to the power 2. The base is the same, which is 3. Simply subtract the powers. 5 subtract 2, you get 3 cubed, which is 27. The next law is what we refer to as the power law. And here if you're given a raised to the power m into brackets raised to the power n, you simply get the product of these powers, m times n, and this will give a raised to the power mn. An example, 2 squared, everything raised to the power 3. You can work out this one by simply opening the brackets by getting the product of 2 and 3. So it will be 2 raised to the power 2 times 3, which will give 2 raised to the power 6, and this will be 64. The next one is the negative index. If you have something like a raised to the power n, this one simply means it is 1 divided by a raised to the power n. And we give an example for this. If you have 2 raised to the power negative 5, this one is equivalent to 1 divided by 2 raised to the power 5. And this will simplify to 1 divided by 32. We also have another scenario. In case you have a divided by b, everything raised to the power negative n. This is the same as b divided by a. You can see this is the inverse, then raised to the power positive n. An example, 2 divided by 3 raised to the power negative 2. You can write that on as 3 divided by 2 raised to the power 2, and this will give 3 squared. You square everything, the numerator and the denominator. That is 3 squared divided by 2 squared, and this will give 9 divided by 4. The other one is what we refer to as the zero index. If you have a raised to the power n divided by a raised to the power n, you notice you're dividing from the second law, the division law. You subtract the powers, n subtract n, and this will give a raised to the power 0, which is equivalent to 1. Any number raised to the power 0 gives 1. An example, 3 squared divided by 3 squared. You solve this one by taking 3, subtract the powers, you get 3 raised to the power 0, and that will give 1. The other one is the fractional index. Given a raised to the power m divided by n, this is equivalent to 1 divided by a raised to the power n. into brackets everything raised to power m. And this one can also be simplified to the nth root of a everything raised to power m. An example, if you have 27 raised to power 2/3, you can simplify this one by writing it as 1 divided by 27 cubed, then everything you square that, and this one can also be written as 27, that is the cube root of 27, then you square everything, and this will give the cube root of 27 is 3, then you square that, you get 9. To wrap it up, some important piece of information about indices, where a, b, m, and n are integers. If you given a raised to power n is equals to a raised to power m, then n is equals to m. When the bases are the same, from the left hand side and the right hand side, we have a as the base, the right hand side you have the same, you simply equate the powers. The powers are equal. An example, 2 raised to power x is equals to 2 raised to power 4. You can see the bases on both sides are 2, they're the same, so you simply equate the powers. X is equals to 4. And also, in the other case, a raised to power n is equals to b raised to power n. So in this case, you can see the powers or the exponents are the same. So in this, then a is equals to b. That is when the exponents or the powers are equal, the bases are equal. The bases here are a and b. An example, we have x squared is equals to y squared. So you can see the powers are the same. That is power 2, power 2. So in this case, it means the bases are supposed to be equal. That is x is equals to y.